Hello, dear friends. This is Dr. Pramod P. Today, we will discuss an important topic related with the simulation of asynchronous counter, up counter using LT space. As usual, let's start with the double clicking on the LT space icon on the desktop and it will appear like this. Go to File, then click on New Schematic. Then the window will appear like this. Then move on to Components, click on that. In that, click on Digital. Then you will be able to find a D flop over there. Means it's a symbol for D flip flop. You will be able to find D input, clock input, then Q bar, then preset clear everything. Then you can duplicate it just clicking and dragging it over there. And since I am building a 4-bit counter, and basically I am in need of four such symbols, so I am placing it likewise. Then after this I am selecting voltage source over here, then that is given to the clock. So the clock, a single source is required over here, and as far as up counter is concerned, q bar of a particular stage is given as the clock of the second stage as indicated over there. And we will proceed this way. Q bar of each stage is given as the clock input of the next stage. Now for setting parameter values of voltage source, right click on the voltage source and it will appear like this. Select advanced over here and new window will pop up. In that we need to give the values. Now the parameter value settings of the voltage source is like this. V initial value is 0, V on is 5, T delay is 0, and I have given T rise and T fall as 1 ns and T on as 20 and T period as 40 and N cycles, number of cycles as 20. You can change it accordingly. Now an important point related with the connection. Usually we are giving a Q bar to D, so that initially Q will be equal to 0, at that time Q bar will be equal to 1. So that 1 is given back to D input. So whenever clock is getting activated, that D will be passed over to Q. So 1 is passed to the output. So likewise for each flip-flop over here, the adjustment is like this, or the connection is like this. Q bar is given back to D. Once the connections are as described, let's move on to simulation. Click on simulation button, then a window, black window in this case. Over here it comes like this, and we need 5 waveforms altogether, 1 clock and 4 flip-flop outputs for the counter. So we need to have 5 waveform sections over there, splitting it like this. So we have 5. Clicking on the first one on top and click on that, and now move to the circuit section. Click on that and select the touch. When the pencil mark comes, the new waveform came. Then the second waveform section, then select that. You will be getting the QA output over there, that is LSB. And now moving on to the next least significant, that is QB over there. Yes, it came likewise. And the third one, that is QC over here. It is selected over there. Just move your cursor. That pencil mark came, red mark came. So click on that, it will come. Click on the yes. Repeat the same procedure for the final waveform also. Click on there and go for that red indication over there. Then click on that and finally you will be able to get it over there, the waveform for the MSB, almost in violet color there. So that's all about the waveforms. It's all about the circuit implementation, design, implementation and simulation. So that green color indicates the clock. Then we have 4 waveforms together. Hope it's enough for you. Thank you all for watching this video. Have a nice day.